Good afternoon, everyone. Honorable guests, colleagues, students, welcome to a seminar entitled Smart and Sustainable Meili 2040. My name is Per Lundqvist. I'm professor in energy technology and I've been involved in this course several years. Recently, Hatef Madani here. Okay. Thank you. So Hatef has been very actively in the course during the spring, and we are about to listen to some of the best and most prominent results we have from the students. Before we start doing that, there are a few things that I would like to say. We are going to record this session. We are broadcasting this live. So I would like you to try to not use your phones, not update social media so actively because we are a little bit short on broadband. So please save for the broadcast. And I think we are going all the way to China. We have quite a dense program. Moving out of the light again, otherwise I won't see my notes. I'd like to especially welcome Dr. Dieng Zhao from Chinese Embassy. Great to have you here. Firstly, I would like to turn over to one of our old colleagues, Professor Emeritus. I think we can say that now, Raman Reis, that worked extensively with relations, especially doing a lot of great job for KTH. Bring in a lot of contacts with China. So I would like first welcome Raman to say a few words. Please.
Thank you very much, Per. It's a great pleasure and honor for me to be here. I've been serving my name is Raman Reis, and I'm actually a nuclear physicist, and actually theoretical nuclear physicist. But I've been working with international relations as vice president for KTH for many, many years. And I really love this kind of projects. And therefore, in particular, I want to wish all students very much welcome, because I think you are the main person and you are the future of KTH and of Sweden and of our globe. So, and when you are retired, it's very nice. You can do what you want. And sometimes you do more than you did before. And actually today I put on, I even brought a tie with me for this special event, but it's just too warm. This fantastic weather at the end of August, I even can't take my jacket on. So a few words about this project. I heard early on the project of Wuxi by Pelle, where students made a study of eco-city Wuxi. That was even before the big expo in Shanghai, and it was supposed to support the Wuxi in its development to become a more eco-friendly town. And I was very, very much impressed of that study, and it taught me a lot. It taught me many, many things. And one of the most important things it taught me is, of course, the system aspects are very, very important. I mean, normally we engineers are very good in modifying a single thing to make it improve it. But if you just improve the single subject you work with, you may forget the surroundings. That one thing, a component, is just a part of a bigger system. And unless you really look at the system aspects, you may work you may direct your work in the wrong direction. So system aspects I learned from that study how important it is. Secondly, I learned teamwork is so important. Because a single student, of course, you work on your single subject. But if you work together, you can bring in the system perspectives. So having teams of students working with systems, that is really can bring about a big change. Normally, we say that the ambition of science is to understand the world. Then the role of the engineer is to change the world. Nowadays, we want to change, of course, the world to become a better place. I mean, we have many, many challenges. And cities are a driving factor for sustainable development because lots of energy, carbon, CO2, and so is produced, is emitted in cities. And unless we get the ecosystem, our cities, balanced, CO2 neutral, we won't manage a sustainable future. So this is why I think cities are really one heart of the problem. So having studied the report at that time from Wuxi, I think the idea to work with teams of students for sustainable development is really something that paves the way for the future. This brings me to the third aspect that I learned from this project and which I still learn a lot about. Is normally when you start a student, I mean the first class you take in mathematics, and you get something what I would call a well-defined problem, and there is a well-defined solution. And then after a little later you start with numerical analysis, and then you learn a little bit about less well-defined problems, ill-defined problems, where you have many solutions. And you have to do a little bit further digging into understanding. And if you look at the world, actually, it's not even ill-defined problems. I think the world is very, very complex. We speak about wicked problems, where you have to really get the system understanding and try to see how certain solutions can work for a more sustainable future. I think that's very important, particularly as an engineer. It's very easy to dig down to your single device, your microphone, and make it better, and see how does a microphone works in this room, how does it interact with you, all people around. I think this is the third aspect I want to emphasize. If you can do this in international settings, it of course opens your mind. It brings part of the world to KTH and KTH out into the world. I think it's really one of the best things that are done KTH are this kind of students project where we work with systems, you work in teams, and you work in complex problems. Once again, I think you have done a great job, and we're very curious to see and listen then to your reports. And I wish you success then, in particular in your future career, because we need you for the future. Thank you very much for being here.
Thank you, Raman. Before we start looking at the presentations, I think it's a good idea that we give a chance for Professor Madani to present this year's, let's say, call it this year's challenge or project. So I guess you prepared a few slides to do so, right? Yeah. So, excellent.
Thank you. Thank you, everybody. I mean, most of you know me. We've seen each other, especially students. We are just a part of course energy management. That's why we are here. And this is a part of, mainly part of the Sustainable Energy Engineering program. And I'm representing the teachers team here. So I'm Hatef Madani. I'm associate professor at KTH. And I'm also course responsible and examiner of the course. And representing also the other teams. You've seen Professor Lundqvist. He was the founder of the course. He's still highly involved in the course. And we have Nelson Sommerfeld is here. He's highly involved in the project, very helpful to the students, and very big help in our team for every year for the course. And we have Chang Su here. Also, he was very helpful, and I can say that it was impossible to do a project on China without his help. So that's thank you very much for this, all those great effort. I will just give an introduction about what the course is about. This is what we put as a course, like a message at our PM that is like at the beginning. So it's broaden the students' ability to cope with analytic and strategic issues related to energy systems and management. And we do it a lot through the system thinking modeling. And if you recognize already the Sustainable Development Goals, we touch more or less any of these 6 ones. You will say for the good health and well-being, from the students' presentation, you will see some of the groups that are working on specifically also for the air quality issues, affordable and clean energy or smart and sustainable cities, the core topic of the project, and the rest. But the most important thing is that the students experience solving a complex problem at a system level, which is a district or city level. As Ramon said, is not well defined, and sometimes we can say that it's not defined at all. And I think that this is very important. Whatever we see, we were just guiding and then helping the students. Most of the job was done by students, and then the student did a very good job of going this journey with us, just trying to learn how to solve a complex system problem at a city level. And we use bottom-up approach. So if you listen, you will listen to the presentations here, and then there are some of them are, we tried not to be very technical, but behind every presentation is like 50 to 100 pages report with so much technical details behind it, and then you can get access to that one. So it's a lot of work behind the things that is done, and it's bottom up. So we were talking about the technical details. We touched a bit system thinking, system analysis and modeling, multi-criteria decision making, because we had many criteria to deal with. We had energy economics. You will see few slides specifically about these Pareto fronts, because we don't want to just say that, okay, this is a solution, no matter what is the cost. We want to know that is like, what are the cost viable, economically viable solutions also. And then where can we move forward in the real life based on those economic values. Business model innovation, you will see the slides from the students about that, and they will talk a lot about their scenarios. So we tried each bit of those things in the course, but around one big project. So we started the course by just a mission, and that was a project that we opened. And this year we identified this specific geographical location, but it always should need to be identified either by us or the students. And we had 3 explicit objectives and goals to reach. And they were like this by 2040. And those objectives were possible and hopefully probable. The reducing the primary energy demand by a certain amount, increasing the share of renewable energy, net zero CO2 emission rate, and there was a 4th additional objective set by the student themselves. So each group was setting one additional goal that it was based on what they identified as a key pain point in their city. As Par said, we were running this for several years. I can show you an example of the previous year's project. We were running it for district all over Europe from 2015 to 2017. We were running it for KTH campus, 2013, same project. We were running the same project for different districts in Stockholm, 2014. We were running it for Wuxi, 2012. And we were running it for different islands, 2010 and 2011. These are the name of all islands all over the world. And last year was a bit more than that, because we had an industrial sponsor. So we had a Japanese company coming to us and sponsored the travel for one best group to Tokyo. So, and then we had the project about Tokyo. So that was Sustainable Tokyo 2040. And that was, first it was supposed to be one group. And then we had such an event, similar event. And then they decided to increase it to 2 groups. And then we had 2 groups winning. And they went to Tokyo. We traveled to Tokyo. We presented for the Tokyo Metropolitan Government. And then since 20 groups were working on 20 wards. Tokyo has 23 wards or districts. And each group was working in one district in Tokyo. So they were presenting their result to the municipality of that ward. So it was in Nakano and Minato, 2 wards in Tokyo, and then we were going and we were presenting there, and we had a nice discussion there. And this year project, that you will listen to it, has the same format as the previous year. It's a Smart Sustainable Meili 2040. And you will listen to the top 5 groups presentation today. And then we will have a winner in the end of that. And the winner is sponsored by the Changshu government, Meili government, to travel and present there. And we will also go to Shanghai Jiaotong University, and we will present in Shanghai as well. Just to show you there's some scale thing, is that we had about 100 students this year. Last year we had 120. So, and then they are coming from all over the world. We are coming from all over the world, I can say. And we are working, and we were working for 20 weeks together to show you how they are coming from. This is not from this year. This is from last year. We need to update it for this year. But that was last year where the students are coming from. And we were literally from all over the world, working on a project about Tokyo in Sweden. And about the events timeline, where we are now, already students submitted about 1,000 pages of report. And then they got their own grade, and then it was the course that it was running in parallel, nothing about competition. And then they were presenting also. There were 16 groups. They were presenting their final work to the expert panel, including the Changshu, the representative from Changshu government were online and listening to us. And then here we are. Now we are at the KTH event. The top 5 group present from for you, and then we will have the winner. And the next step is in end of September. We're traveling to China, and we will present there together with the winner from today. Thank you very much. And then I invite you to listen to the presentation from the students then.
So I think it's the first presentation is group number 6, correct? Okay, so please, I think each group will talk for maximum 12 minutes. That's and then down after the seminar we have some refreshments, and we have posters in Sing Sing building at the bottom floor called Plattan, for those who know in Swedish. So there will be a lot of opportunities to talk to each group there and ask more particular questions. So now we run the presentations, and then we try to take notes and say what are our questions, and then we run the groups. And then I think that's the format. Yes, okay. So I'm giving the word over to you, guys. So please take the microphone.
Thank you. Hello. Hopefully everything will stay put and it will work. Yes, we do. Perfect. Hello, we are KTH Energy, and we are delighted to be here today to present our vision of a smart and sustainable Meili town 2040. As we've just heard from Professor Madani, we were tasked with developing energy systems for a higher quality of life, and our work has considered the challenges facing Meili town and China today. Our vision is bold, but achievable, delivering a low-carbon energy system to the district. Our vision is a scalable solution which can be implemented in surrounding areas as well as other districts in Jiangsu. And our vision secures the continued economic growth of the district, providing jobs and meeting the energy security and cost requirements for the local government, without making disproportionate claims on the district or the surrounding area to be implemented by the local people. These are the 3 KPIs, which were key performance indicators, which were given as part of the project brief, as Professor Madani has touched upon, but we've also added a 4th. To improve air quality, to be compliant with the World Health Organization. Air pollution is a major problem in China and across the world, and in China it is attributed to over 1 million deaths per year. It causes things such as heart disease, lung cancer, as well as strokes and respiratory infections in children. Our visionary plan sets Meili at the forefront of the Chinese battle for blue skies. But we have also considered national policy and planning in our project. Our vision takes into account the Chinese nationally determined contributions. These are part of China's commitment to the Paris Agreement, which seeks to tackle the effects and causes of climate change. In the nationally determined contributions, it focuses specifically on peaking emissions by 2030, increasing renewable energies, and decreasing the carbon intensity of the country. And we've also considered more short-term plans that China has, such as dealing with the challenges of urbanization, energy efficiency demands, air quality, and transformation of industry. We believe that our plans will deliver a full package of solutions for a smart and sustainable Meili Town 2030 with benefits to the economy, the environment, and the society.
Right, so this was our introduction to our vision, but then how will we achieve it? We will propose a number of energy system development options spread upon the key sectors of the district. So first off, we have the built environment, which includes residential, commercial, and public sector buildings physically located within Meili Town. And here we're proposing the implementation of high energy efficiency technologies, solar water heaters to meet the heat demand of residents, and heat pumps for central heating, a commonly used technology in Sweden, which is also suitable thanks to the climatic region of Meili Town. Secondly, we have the transportation sector, where we think that electrification and fuel switching are viable ways to achieve decarbonization. As China is a leader within battery technologies, we have assessed a 100% electric car fleet as well as a electric bus fleet within the district. And although electric trucks are being developed, we have assessed that fuel switching from diesel to liquefied natural gas is a viable way to have the transport industry moving forward within the district. So then we have, thirdly, the energy supply, and Meili Town is connected to the Chinese national electricity grid, which provides most of the heat and power within the district. Alongside with this, we have proposed the implementation of a combined heat and power plant fueled by the municipal solid waste of the inhabitants of the district. And furthermore, we have looked at the implementation of rooftop solar PV over accessible rooftop areas. And finally, we have industry, which is the largest contributor to the district's economy. And we've assessed this in two parts. The first part is the steelworks, which is both the largest energy consumer, but also the largest emission producer in the district. So therefore, we have proposed the implementation of a new smelting process being developed by Tata Systems, which should possibly reduce both the emissions and the energy demand by 20%. But then furthermore, we have qualitatively assessed a pioneering Swedish innovation called Hybrid, which stands for Hydrogen Breakthrough Iron Making Technology, which then uses hydrogen instead of coal from the electrolysis of water to entirely decarbonize the steel making process. In other industries, such as textile and manufacturing, we have considered energy efficiency improvements, such as the implementation of industrial variable speed drives to lower energy demand in the sector, and then also the fuel switching from coal to natural gas in order to further reduce emissions and improve the local air quality. So in order to evaluate these system energy development options with regards to the key performance indicators that we have presented, and also taking into account the economic and resource constraints of the district, we assessed the position of Meili Town using data from 2017, and then we modeled a business as usual case based on the present day and future trends, both on a local, regional, and national level, to predict but to create a vision of what Meili Town could where Meili Town could be in 2040 if no actions were taken. And then we applied our energy system development options onto this vision in order to see how effective our options were.
Thank you. So, looking at our results from a key performance indicator perspective, let's take primary renewable energy first. So here in green, we have where we are today with data from 2017. In yellow, we have what will happen in 2040 if we do nothing based on current trends. And in red, we have our vision of Meili Town. So here we can see that in 2017, 5% of the energy supplied to the district comes from renewables, which increases to 6% based on projected trends. But with our vision, we've managed to raise this to 51%. If we also include CHP, combined heat and power plant, that we plan to install in the district using waste from local households, this will increase to 80%, making it low carbon energy sources a key feature of the district. If we look at energy supply, which also includes industry, transport and buildings, you can see that the energy demand of the district will rapidly grow as this is in petajoules. Now, if we consider just buildings alone, growth in building energy demand will increase by over 200% in the next 2 decades due to urbanization and changes in consumption of fuels due to affluence. But with our energy system development options, this will decrease by 18%. In our vision of the future, the carbon emissions will be 400 kilotons lower in 2040 than they are if we do nothing. Moreover, our results show that carbon emissions will peak in 2030 as in tandem with the nationally determined contributions of China in the national policy and planning. And finally, improved air quality is dramatically improved. Although this graph only shows particular matter of less than 2.5 microns, across the board in our results for other pollutants such as nitrous oxide, sulfur dioxide and ozone, we've seen the same trend. From this graph you can see particulate matter 2.5, which can easily penetrate the lungs and enter the bloodstream, to be equivalent in our vision of 2040 with where it is today, and it will in future decrease further. Despite the increase in energy demand and electricity generation within the district, air quality will improve in our vision.
Right, so we do have a lot of results, trust us. And although we would like to show them on a per sector basis as well, the time is limited and we cannot really go into the details of them. So instead I will just give you the highlights, and if you're interested in more details, you can always come talk to us at the posters after all the presentations are done. So for built environment, we see that energy demand is reducing and carbon emissions are even decreasing below the current levels, although the huge spike in 2040. For transportation, we see similar results, and thanks to the electrification of the transportation sector, the energy supply go down and the emissions are lowered by 30% compared to 2040 if no actions were taken. Within industry, we see a reduction of about 20%, both in energy demand and carbon emissions, thanks to the new smelting process implemented in the steelworks, as well as the increased use of industrial variable speed drives in the other industries. However, if investments are being made into the Swedish process of hybrid, the hydrogen-making steel process, the potential to reduce the steelworks emissions go down to zero. So there are huge potential there. And then finally, the energy supply. The CHP plant may look small and it's sized at 3 megawatts, but this is due to the resource capacity with the municipal solid waste generated by the households in Meili Town. And this can be expanded further if Meili Town decides to import municipal solid waste from other districts in the area. We see that the dependency on coal reduced from 76% in 2017 to around 14% in our vision. showcasing the great potential of rooftop photovoltaics.
But now let's talk about cost, because nothing in this life is free. So here we have the marginal abatement costs of our energy system development options. On the y-axis, we have the cost per ton of CO2 produced, and on the x-axis, we have the cumulative savings of CO2 for the period 2017 to 2040, which was the period where we studied. Now, as you can see, some technologies have a high cost, but equally they have a high impact at lowering emissions. And if we take variable speed drives as an example, it has a negative cost because of the energy saving it incurs, which also helps to reduce emissions. But our energy system development options, our solutions we present, are a package and can be deployed dependent on the local government cost and resource requirements. So this is our vision. We have developed a technically feasible range of options for a future low-carbon energy system that meets the needs of Meili town. We have considered the vision of the district's future from the local, regional and national perspective, making it not only a safe and sustainable district, but an attractive place to live. With appropriate local government support, public awareness and long-term planning, we truly believe that Meili town can become smart and sustainable. Thank you for your attention.
And the next group is 11. Please. Does it switch automatically? It should be next slide. Fantastic. Who is going to start?
Hello, everyone. First of all, we would like to start our presentation with the main motivation behind our project. As you can see in the video, that it shows the global mean temperature that has been increasing around the world in the past few years. Over time, it's increasing more rapidly and with higher peaks in temperature. So we need to take action now. And thanks to the collaboration between KTH and Meili town, we have been able to apply our research and whatever we have studied theoretically into a practical project. Step one would like to present the smart and sustainable Meili plan for 2040. Moving on to the main aim for our project, the main aim is to create a sustainable and replicable model for a district in China that encourages the society to incorporate sustainability in their everyday life and to promote a positive and contagious sustainable behavior.
The common objectives have been the increase of the primary renewable energy fraction, the decrease of the primary energy consumption per capita, and the avoidance of the net zero of the CO2 emissions. But then we have decided to think about two other goals, which are the conversion of organic waste produced by Meili citizens into biofuels, which can be incorporated inside Meili public transportation system, as well as the increase of non-fossil fuel power transport by means of electric cars and biogas buses. In order to achieve these goals, we have decided to propose different solutions. First of all, for what concerns the energy generation, we propose the installation of solar panels on both rooftops and in a power plant, according to the land availability which the district disposes. Moreover, wind energy seems an attractive solution for Meili because we have noticed that on an annual basis it is more productive than solar, and so it can contribute to increase the primary renewable energy fraction. And furthermore, we have seen that organic waste can be, thanks to waste recycling, converted into energy instead of being landfilled. With this regard, we wanted to use the biogas produced by waste into renewable buses, and together with the introduction of bicycle lanes or reserved lanes and electric car sharing, we want to further improve the air quality as well as the road congestions. In the end, we want to improve also the buildings by means of using appliances which are higher energy efficient in order to reach nearly zero energy levels.
Okay, this graph is a Pareto chart, and every single point is the combination of different accounts of the proposals that we showed before. And every single point different from each other according to the total investment cost, which can be seen in the y-axis, and the primary renewable energy fraction, which can be seen in the x-axis. And Meili has as many possibilities of change as the number of this point. In the Pareto frontier, there are all the optimal solutions, which are the solutions with the same amount of primary renewable energy fraction, but with the lower total investment cost. This is the point that we selected. So this is our proposal for Meili 2040. According to, basically, we chose it according to the land availability of the district. So you already know our technical objectives, so let's talk about the results. First of all, in 2018, there are 2% of the primary renewable energy fraction, while in 2040, thanks to the introduction of solar energy, wind energy, and biomass energy, we can get 57%. About the energy consumption per person, we get a very good decrease. That is almost half of the compared to the base year, that is 2018. Also, the CO2 emissions would be very, very decreased from 181.6 kiloton of CO2 equivalent to 51.2. And the waste, the organic waste conversion into energy can lead us to reach the 60% of the conversion of the Meili waste into biogas, into biofuels, that can cover a big share of the public transportation of the district. And lastly, we took care about the transportation. So thanks to the introduction of electric car sharing, the reduction of diesel vehicles, and the introduction of renewable buses, we can pass from 3% in 2018 to 51% in our goal, that is 2040.
Okay, then, here comes the problem. How can we integrate these changes with Meili people's daily life during the days? As we all know, it is really, really difficult to create a sustainable society if the local people are not willing to take a sustainable lifestyle. Just like the proverb says, give a man a fish, you can only feed him a day. While teaching a man to fish, you can feed him the whole lifetime. Therefore, it is very important to motivate the local people and let them be the main actor on the road to a sustainable and smart Meili. As we all know, Chinese people has a citizen card for everyone. About the citizen card for Meili people, there are 63 different functions. For example, you can buy your public transport ticket, you can pay for your electric bills and water bills, you can refuel your vehicles, you can do business transfer, really multifunction. And then our main point is to add another sustainable function into the current card system. If you are doing the current functions, of course, you are bound to use your own money. But if people choose a sustainable lifestyle. For example, use the renewable buses, rent electric cars, recycle the waste, they will receive Green Award, which is called Sustainable Meili Coin, SMC. On this occasion, you can use those SMCs for sustainable activities. For example, you can buy sustainable food products. You can charge your public transport ticket. What's more, you can gain extra discounts if you want to buy a new energy-saving apartment. In our new system, of course, the engine is a government investment. But as a result of the investments, there are so many promotions could be reached in the future. For example, the development of industries and green agricultures, the spread of green public transport, and the most important, publics willing to take a sustainable lifestyle.
And in the end, we created a short story to try to imagine how the card system can actually work. And the story is about Meili and Meili. Okay, he is Li, and he's a guy who is living in Meili, in these days. And he can use his citizen card to do many things, as we mentioned before. For example, he can buy the ticket for the bus. Li is trying to change his life to a sustainable life, but both the environment, the surrounding environment, the government, and also the society are not really encourage him in his choice. So he's sad, but suddenly a portal is open and a figure is appearing. She's Mei, and she's coming from the future, and she grabs Li and takes him to her reality. So this is Meili in 2040, as we can imagine, like with all the proposal that we made. And now Mei, she can show Li how her card is working in 2040. The functions are almost the same. She can buy the ticket for the bus. She can, for example, rent bicycle or electric car from the car sharing, or she can buy sustainable products like organic food. But the difference is that she doesn't have to pay with her money. She's just using the coins that she earned before. So Mei wants to give a gift to Li, and she gives her card. And Li can travel back to his Meili. And then, after his journey, Li arrived in his Meili with a new hope, like that things can change, and he knows that he needs just one single step, to make everything changes. Thank you for the attention, and it's all.
Very artistic. Next group is number 12. 12? Yes, correct. Do we need one or two microphones? One, two. There's one there, and I think they're both live. So.
Good evening, everyone. We all are here today because we understand the importance of acting against climate change. With increasing global temperatures, every country across the world has taken up goals and policies to mitigate climate change. Having a smart and sustainable community and city is one such goal. And sharing this common goal is the town of Meili. Meili is a small town in the Jiangsu province of China. With a population of 140,000 residents, Meili boasts of an annual GDP of 8 billion yuan, thanks to its immense industrial sector. So what are some of the goals set by Meili town? By the year 2040, Meili wants to have a renewable energy share of 80%, reduce the per capita energy consumption by 50%, and have a net zero carbon dioxide emissions. Lastly, air pollution is a major problem in China. So this is the fourth goal we have chosen. By 2040, we want to reduce the per capita emissions by 35%.
We are Odin Energy. We are a group of 6 engineers coming from 4 different nationalities, coming together to solve the problems in Meili. We have used 3 scenarios using 4 different softwares. Here we can see the electricity production in China in the year 2018. We can see that about 88% of the total electricity produced is done by fossil fuels alone, mainly coal and natural gas. So as a sub-KPI, our team has decided to concentrate on reducing the dependency on coal by the year 2040 by 80%. Moving on to the electricity consumption by different sectors, we can see that industry tops them all. Industry sector consumes about 91% of the total electricity. And more on that, about 70% is consumed only by the steel industry. So my team and I, we believe the steel industry to be the neon monster, a monster which prevents the longevity and prosperity of Meili. Chinese New Year is celebrated by killing this neon monster. So we believe we have created 3 different mythological heroes to fight this neon monster.
We begin with the Monkey King. The Monkey King, initially egoistic, wanted to rule over the entire world. But he later understood the repercussions of his own actions and instead wanted to be the protector of monks. China annually has a lot of carbon dioxide emissions, but they are taking up a lot of policies and goals in order to change the status quo. And we believe this is an accurate representation of the Monkey King. Hence, this scenario is our business as usual scenario. Secondly, there is a statue of the guardian lion present outside every important building in China. It represents a secure and stable future for the country of China. By implementing renewable energy solutions, we make the guardian lion scenario the most secure scenario for Meili town. Lastly, we have the Dragon Warrior, where we have implemented technology that are still upcoming, but are promised to be commercialized by mid to end 2030s. So this is our technological boost scenario. For the sake of this presentation, we will be focusing on the Guardian Lion scenario, as the solutions presented here are the ones recommended by our team. We will specifically be focusing on the steel industry, as it is the largest consumer of energy and electricity in Meili. To begin with, we have separated the consumers as industrial and non-industrial consumers. Non-industry includes residential, commercial, and the transport sector. We started off by implementing rooftop PV on all new buildings. We've implemented grade 1 electrical appliances in all new buildings, and old buildings will shift from grade 4 to grade 1 over the next 5 years. To give a brief explanation, grade 4 electrical appliances are the lowest efficiency, and grade 1 has the highest efficiency. Furthermore, we have increased the thermal capacity of buildings, which reduces the amount of heating and cooling required during the winter and summer seasons. Along with the efficient appliances, this gives an energy saving of up to 40% per building. We've converted all cooking stations from fossil-based to electricity and biogas-based, removed diesel and gasoline vehicles from the roads, and implemented only hydrogen, biogas, and electric-powered vehicles. We've implemented 14 kilometers of covered bicycle lanes and increased the green area in Meili town to 28 kilometers square.
Moving on to the industrial sector of Meili, we have incorporated a new steelmaking process. This is known as ultra-low CO2 steelmaking. Here, we use 4 sub-processes to make this happen. The first one is the top gas recovery. All the flue gases coming out of the chimneys of the steel industries, mainly carbon monoxide and hydrogen, are captured and are transferred back into the blast furnace. By doing so, we can see there's a significant reduce in the carbon input demand, up to 25%. The next process is the carbon capture and sequestration. The flue gases coming after the top gas recovery will be captured, transferred, and stored in an underground pit. The next process aims to reduce the dependency of coal in industries. Here, all the process in industry which requires heat will be using biogas instead of coal, except the blast furnace. And finally, we have incorporated waste heat recovery in all the industries. Any process will have some heat going to waste. Capturing this waste heat and putting it back into the system would act as an additional energy source and would reduce the energy demand up to 25%. By incorporating these four processes of ultra-low CO2 steel making, we can see there's a reduce in carbon dioxide emissions up to 65% and a reduce in energy input by 25%.
In order to implement all these changes, we have to produce hydrogen, biogas, and electricity for Meili town. In order to do so, we firstly need an initial investment of 58 billion yuan for the Guardian Lion scenario. This incorporates a 5 gigawatt large-scale solar factory outside the geographical area of Meili and a 450 megawatt offshore wind plant within the Jiangsu region. Furthermore, we have incorporated a biogas production facility within the Meili region. So we collect waste from Meili, Jiangsu, and other nearby provinces and convert them into useful biogas. Lastly, we have incorporated a hydrogen production facility also within the geographical area of Meili. Here, electricity is used to break down water and produce hydrogen that can later be used in the transport and industrial sector. With that, we arrive at the year 2040. So for the Guardian Lion scenario, at the end of 2040, we have achieved a renewable energy share of 70%, reduced the per capita energy consumption by 30%, and reduced the carbon dioxide emissions by 70%. Lastly, we've also reduced the PM 2.5 emissions by 50%. At this stage, it is very interesting to note how improving a certain KPI can negatively start affecting the other KPIs. One such example would be the incorporation of biogas. If we keep increasing the amount of biogas we use, for sure we are increasing the renewable energy share, but we are also increasing the amount of PM 2.5 emissions. The values presented here are the most optimal values. Increasing any KPI beyond this level will negatively affect other KPIs. These concludes the solutions we have implemented for Guardian Lion. Later on today, during the poster presentation, we will be discussing the results from the monkey scenario and the dragon warrior scenario. In the dragon scenario, we have implemented the hybrid steel solution, where we use methane and hydrogen in terms of reduction instead of using coal as such. We also have an innovative business model for supermarkets, which we will be discussing during the poster presentation. For now, we believe by implementing these solutions, Meili town can truly defeat the neon monster and have a Gongxi Fatsai. Thank you.
Good afternoon, everyone. It's good to see everyone after the entire summer. And we are group 13. It's Michael, Thomas, Amber, and I'm Ming. This is Meili's current energy situation. In 2018, Meili consumed in total more than 20,000 gigawatt hours energy and more than 2.4 gigawatt hours electricity. Of all the energy they consume, most of it go to the industrial sectors. Steel industry is the biggest energy consumer in Meili and also the biggest industry in Meili. As for the electricity generation, Meili is working on its energy diversification. It's a hybrid grid of wind and solar, However, its biggest energy producer is still thermal power generation, and it burns coal and gas.
Right. So, judging from the current situation, it is apparent that the industry sector is one of the larger consumers of Meili. So even in this project, that's what we mostly focused on. So in Meili, in the year 2018, it produced around 7.4 million tons of steel. And because of that, it consumed 90% of the annual energy of the town, as well as emitted 90% of the annual carbon dioxide emissions. As can be seen from the figure to the right, which is taken from SSAB, which is a Swedish-Finnish company which specializes in producing steel. It can be seen that coking coal is a large fuel that is a big fuel that is needed in the steel production. Around 1,600 kilograms of carbon dioxide is emitted for every ton crude steel that is produced. So our vision for Meili to make it a sustainable and a smart city is to increase the renewable energy share of 80%, to have a net zero carbon dioxide emission rate, as well as having 100% fossil-free transportation. In order to reach these goals, our main goals are to have an electric transportation, is to install low energy buildings, as well as having a fossil-free steel industry, and implementing external power generation for it to get renewable electricity from. For the steel industry then, to convert from the conventional steel production that it has today, our solution is to implement the hybrid solution. Using hybrids is short for Hydrogen Breakthrough Iron Making Technology, and it's a joint venture between SSAB, LKAB, and Vattenfall. Here, instead of using coking coal, it uses hydrogen gas instead, and the byproduct being then water and not carbon dioxide. However, using this process, you need a lot of electricity, which means that rather than coal, the electricity demand will increase significantly.
And our solution to the increasing electricity demand is that we suggest to build external power generation. And where to build it, we suggested in a place called Nantong. There are several reasons why we choose this place. Nantong is just on the other side of Yangtze River from Meili. So it's very close to Meili. And Nantong, it has a very long coastline. From Rudong to Haimen to Jiuru to Qidong, it can provide more than 100 kilometers coastline, and it is coastline to shallow sea. It has a very good potential of developing wind farms. Now there are already several small wind farms in there, and we need to integrate it. If we integrate it, it has a potential to become the biggest wind farm in China, offshore wind farm in China. It's also the same condition in Haimen, where we want to build a solar park. Longan Energy Company has already developed a small solar park in Haimen. And what we need to do is that we need to enlarge it, because it runs really well, but it needs some investment.
So to explore different possible futures for Meili, we created 3 different scenarios. The first one is business as usual, and it's basically following the current policies. And then we have the realist scenario and the idealist scenario. And the difference between these two is basically how aggressively Meili manages to follow the suggested solutions. And the biggest difference between the scenarios is how far they go in our solution to electrify the steel industry, and also how much external renewable electricity Meili managed to build outside of Meili town. So the results, so first looking at the renewable energy share For the business as usual, it's very low, just a few percent. And for the middle scenario, it's still below 20%. For the idealist scenario, it's up over 60%. And the difference you see between the two differently colored bars is to show like the real impact that external renewable electricity has. Then if we look at the carbon dioxide emissions, so this presents reductions compared to the BAU, the business as usual. And for the realistic scenario, it's around 30%. And for the idealist scenario, it's over 80% reduction in carbon dioxide emissions. This is including a lot of solutions in different sectors that unfortunately we don't have time to go into all the details of. We are very happy to expand on that during the poster presentation. But the really large gains in carbon emission reduction is from electrifying the steel industry and providing that electricity with renewable electricity.
So the problem right now with electrifying both the transport sector and the steel production is that the grid mix in China is not very good. And the grid mix is the carbon dioxide emission associated with electricity generation. Just to compare, in Sweden, right now we have roughly 50 grams of carbon dioxide per kilowatt hour, and in China they have between 900 and 1,000 grams. So what we found out when we dug into the hybrid problem a bit more is that with the current grid mix, the total carbon dioxide emissions are actually roughly the same, around 9 million tons of carbon dioxide. So, however, if we were able to power the steel production with an external power generation, that's where you could see the most changes. So, able to monetize this, we interpolated the price of the carbon dioxide emissions to roughly 300 yens per ton. So here we can see on the x-axis is the carbon dioxide in-grid multiplier. So at 1, it's the current grid mix into 2040, and at 0.1, it's 90% reduced. And there we can see that the economic gain is roughly $2.5 billion yens just by savings in the emission costs. So our conclusions and recommendations for Meili Town is to electrify the transport sector, build new energy efficient buildings, but most importantly is to electrify the steel industry and supply it with renewable electricity. Thank you.
Last group, number 15, right? What's to start?
Thank you. Hello everyone, we are Group 15 and Team Inspire. We are really grateful to be here today, and we hope that you will enjoy our vision of a sustainable Meili Town. The green bar that you see on the top of this slide is the progress bar, and this bar will guide you through our presentation. Our main task in our project were to develop or deliver recommendations for a sustainable Meili Town. And early on in our project, we decided to focus on the people, because we think that people is the foundation of a sustainable Meili Town. Here you can see our 4 KPIs. You heard a lot about the first 3, and we will talk a bit more about our own KPI 4, we set a goal to reduce the PM 2.5 emissions, and we set the target to 10 micrograms per cubic meters. We believe that this is a very important KPI because I forgot it.
Well, it's related a lot to people, and it has like social, economical, and environmental benefits.
Exactly, as I will talk more about here. So our KPI 4 is a way to measure air quality and, to be more precise, the concentration of PM 2.5. PM 2.5 is particles that is smaller than 2.5 micrometers, and high concentration of this can cause serious health issues such as lung cancer and respiratory diseases. On the other hand, low concentration of this will benefit both in social, environmental, and economical aspects in a society. The World Health Organization have set an interim standard of 35 micrograms per cubic meter. And more globally, they recommend concentrations lower than 10 micrograms per cubic meters. And this is where we have set our target for KPI 4. This picture might look a bit complex, but developing this model really helped us to identify our focus areas and also to keep track of all the flows within our systems. The flows are represented with the arrows or the lines, as you see, and the model boundary is the dashed frame around the system. The circles outside this frame is resources that we can't change or affect, but we can still utilize them within our system. We have developed 4 different scenarios. The first one we call DOG, which is business as usual, and is based on current trends and current state, and they will stay unchanged until 2040. Moreover, we and Tiger, which are our own scenarios where we can set our own goals where we want Meili to be in 2040. Our most aggressive scenario is Dragon, where we wanted to fully decarbonize the mobility fleet, and we would like to minimize the heating demand in the residential sector, and we also wanted to build a waste to power plant with the biogas production. And in order to fulfill these goals, we developed initiatives that Monica will tell you more about.
Yes, thank you, Philip. So our initiatives are sort of like the steps we have to take in order to reach our goals. So it's like a how-to, basically making it more concrete, more grabbable. The initiatives you see here on the slides are for the Dragon scenario, which is the most ambitious one, but which we end up choosing. So you can see in the mobility sector, for example, we have teleworking, that is working from home. We have ride and car sharing, grocery home delivery. We also have a big switch to renewable fuels. In the built environment, we have, for example, electrification of cooking. We have heat pump installation, and we also introduce a lot of green space to combat this air pollution problem. In the energy sector, we have, among other, like rooftop solar PV, wind. We also install a waste to gas plant. How we model our vision is by using the following tools. So we use Excel, Leap, and Homer Pro. So we take the initiatives and translate them into values, which we then use to create an air quality model and an energy demand forecast. The energy demand forecast is then put into Homer, which what Homer does is basically give us many, many different power configurations. So we end up choosing one by using a Pareto analysis. And this is our Pareto analysis for the Dragon scenario. So you can see on the y-axis the cost, and on the x-axis the renewable energy fraction. And what's important to understand here is that all these little blue dots that you can see represent a certain future. So a certain power configuration. And where you want to be is on the green line, because that means that either you have the lowest cost or the highest renewable energy fraction. And our group, our team, of course, thinks a high renewable energy fraction is super important, but we also want to have a realistic scenario, and that's why we go for the cheapest one. And when we do that, we end up with the following optimized power model. So you can see we have 22 megawatt of solar PV placed quite centrally on the rooftops of the city. We have 16 megawatt wind placed a bit outside in the rural areas. We also want to utilize what's like inside of Meili. So we have a waste to power plant and we introduce a biogas digester. Worth mentioning is that we also have ethanol imports and we do rely a bit on the grid. And the final uses include like residential cooking and heating, and a big part is for like the vehicle fuels, the renewable ones, because we want to move away from the fossil ones.
So, thank you, Monica. Yes, so the Dragon scenario had the best performance for all 4 KPIs. And these are the highlighted results that you see here. For starter, the 74 megawatt of renewables added to the system will increase renewable energy fraction all the way up to 63%. China is a leading example when it comes to the individual energy awareness. But with our initiatives that we are taking in the Dragon scenario, as Monica mentioned, we can reach even greater energy efficiency, decreasing the primary energy supply with 22%. For KPI 3, the system configuration enables a 30% reduction of CO2 emissions compared to 2018. For KPI 4, a 30% reduction of PM 2.5 concentration is achieved. This is not the 10 microgram per cubic meter that we were aiming for, but 27 microgram is well below the World Health Organization's interim recommendation for China, which is 35. The economic rate of return for the system is around 6%, and it will generate a profit of 581 million RMB in net present value. And these positive numbers shows that the system will be profitable. The benefit cost analysis of the system indicates that 1.2 RMB will be gained for each RMB invested in the system. But the benefit cost for the system should, however, be higher due to thanks to the environmental effects, environmental increase in the air quality improvement, which will lead to cost savings within the health sector. China is a progressive country when it comes to implementing innovative solutions into the society. And as our system took form, we identified a business opportunity that we call Inspire, which will further enhance the infrastructure and the electrical grid. With the expected increase of electrical vehicles and PV panels, the strain on the grid will increase. And a load-shifting solution like Inspire has therefore never been more appealing. Inspire's vision is to empower our customers by helping them to lower their electricity consumption and cost. This is done by connecting your electrical applications and the energy metering device to an innovative IA software. The software then analyzes the data and helps the customer to optimize their electricity consumption, leading to cost and energy savings. This is our contribution. And just on a final note, to achieve a sustainable future, you need to act. And to quote the Chinese proverb, best time to plant a tree was 20 years ago. The second best time is now. Thank you.
Okay, We have now heard 5 presentations. I think we are closing this session now, and we are taking our stuff. And Hatef wants to say something? Yes? Exactly. We're going all the way down into the building Sing Sing. And if you don't know where it is, yeah, exactly. So, and Graverstack, we will have the posters, and we have fika, some coffee and rolls and stuff there. So thank you all for being here, and see you next year.